Hey, Sister Mayo, this is our video for lesson 4.
All right, so for number 1, part A, we said that the null hypothesis should be that the green is dominant over yellow and that the constricted is dominant over the inflated. And then we went through and we did the chi-square table. And so we started out with and we also said that the inheritance pattern should follow a 9 to 3 to 3 to 1 ratio. And so we went through, found our expected values here, and then put them into our chi-squared table there. And when we did that, we came out with 44.35
or around there.
Yeah, 44.35. And so with that value, we decided we would reject the null. And then for the new null hypothesis, we decided we would say it was X-linked dominant.
Mm-hmm. But in order to know that, we need to know how many of the different phenotypes are males and females. So we don't have enough information to know that for sure. And then for slide over. Then for number 2, so 2A asks what the inheritance pattern, which inheritance pattern best describes the co-pigmentation. And we said codominance because when they're heterozygous, they express both black and white spots. It's not like a gray blend. So it's codominance. And then when you cross a true breeding normal black female with a shaker white male, we got for the F1 generation, it's 100% of the offspring have black and white spots, so they're heterozygous for coat color. 100% of the offspring have normal tremors, and 100% of the females are carriers for the tremors. So the females are heterozygous for it, whereas the males are hemizygous and they're normal. They don't have the shake. And then for C, we are doing the same chi-square test and using the information given. There's a total of 26 offspring, and we got a chi-square number of 4.8 or around there. And so we failed to reject the null hypothesis. So that's number 2.
So with number 3, we're working with Cheshire cats. And so we're working with 2 heterozygous parents. And so our dominant thing being the large grin. This being the small one. Yeah, and since they're heterozygous, they're going to follow the same exact pattern of the 9, 3, 3, 1. And so since it being 9, 16, 3, 16. And then with the disappearing or not, I guess this would be a large grin with disappearing. Okay, I'll just put it this way. And then you can have small or large grin rather without disappearing, and then small grin without disappearing would be your least likely one.
So maybe you're going to do this one as a D.
Yeah, I guess it'd be a little D.
Right.
There we go. So this would be our ratios basically. And so with the first one, it says, what is the probability that the first 5 offspring would have small grins and can disappear? Small grin and can disappear, so it'd be this guy right here. And so honestly, you could just do this to the 5th power, and that gives you your number, which ended up being 0.023%. And then the next question asks, what's the probability if 8 offspring are produced 5 have large grins and can disappear, and 3 have small grins and cannot disappear. And this is where we throw in this equation. And so to find that, right, we have 8 events and 5 specifically with the first group. And then this ends up being the second group, the second event. And the probability for that first one, I think it was large. Ended up being the large grin and being able to disappear. So it ended up being that 9, 16 here, with the X being that 5. And then the Q being the second event, which would be the small grin and not being able to disappear. That guy. And so it ended up being 1 16 with 3 after you subtract. And so the answer that came out for that one, after doing everything, is 0.077%. And for C, it says, what is the probability that an individual offspring can have a small grin and disappear, or have a small grin and cannot disappear? So you just combine these two, which ends up being 4/16 using the sum rule, which is 25%. And then for D, what is the probability that the first 4 offspring have large grins and can disappear, and the next 4 offspring have small grins and cannot disappear? And so since it's in order, we had to do you multiply each fraction out. And so which large grins and disappear, that was the 9. I believe it's 4 first and 6. You multiply it by the next 4, which would be 1/16. And then you get your answer, which ends up being 0.0001528%. And then moving on to section 4. This is when we get into like our family tree stuff. And so with this first one, we said it was autosomal dominant, mostly just because it's in every generation, doesn't skip any generations. Who are recessive, it could do that, and there's no difference between the males and the females. But this next one, it's just the males, so we know that it's Y-linked because every father passes it on to their child. This is completely 100% to all the males if they're, if they have that. And then for the next one, for section C, we decided it was autosomal recessive, mostly because the ratio between the males and the females were about the same, and it skipped generations. Another possibility we thought of could be X-linked recessive, but that would be more unlikely since the sex ratios were equal.
And then for D of the pedigrees, we said that it was X-linked recessive, and some of the keys for that were that unaffected fathers had affected sons. Males are more affected than females, so it's not autosomal, and that every affected male had an affected mother, every affected male had a mother that's a carrier. And then it skips generations through female offspring. And since not all males are affected, it can't be Y-linked. And then for E, it was autosomal recessive. It affects the males and females equally, skips generations, and unaffected parents have affected offspring. And that moves on to section 5.
All right, and for section 5, so part A has 2 parts to it. The sum probability rule is used for mutually exclusive events, while the chi-squared test compares the observed outcomes of a genetic cross to what was expected. B, more males are affected than females when a trait follows X-linked recessive inheritance, while an affected male produces 100% affected daughters when a trait follows X-linked dominant inheritance. C, when calculating probability, the word or indicates that one would use the sum rule. In probability, the term independent is used to describe events that have no influence on each other. When a trait follows autosomal recessive inheritance, both males and females are affected with the same frequency, and the trait can skip generations. When a trait follows Y-linked inheritance, affected fathers produce 100% affected sons. F, sampling error is high when analyzing the inheritance of traits in humans because the sample size is typically low. And G, for the purpose of the chi-square test involving genetics problems, the degrees of freedom equals the numbers of phenotype classes minus 1.